Nice to meet you.
Nice to meet you, yeah.
Ciao, Giovanni.
I'm a professor in the Department of Geography at UCLA, and I'm a marine ecologist. One of the main things I study are coastal ecosystems and how climate change and human impacts are changing coastal ecosystems. And I love kelp, so kelp is one of my main areas of focus right now. Trying to understand how kelp forests are changing, trying to understand the importance of kelp and how kelp impacts the huge number of species that kelp forests support.
Yeah.
That's my focus right now. A lot of people, when I say that I study kelp, say, oh, like it's ugly, it's slimy, it washes up on the beach and it smells. And I think it's a issue of perspective, right? Most people only see the bits that are floating on the top of the surface, or they see the pieces of kelp that gets ripped up and washed on the beach. I mean, they're not seeing the forest. Imagine if all you saw was like some of the leaves on the very top of the trees, or you saw branches that fell down on the ground. Like, you wouldn't have an appreciation. Whereas if you get down underneath the water and see like the three-dimensional structure, this kelp can grow up to 20 meters tall, 30 meters in some crazy, extreme circumstances.
And I imagine it's full of fish. Also.
Full of fish and invertebrates, and the light coming through the canopy. It's beautiful, but so few people get that perspective of kelp. Kelp can grow up to a ½ meter a day, which is just like, it's incredible. You can almost see the growth. And giant kelp is the main species that I study here. It's the largest kelp. It grows from 1 meter of depth out to 20 or 30 in at the deepest. It's often between 5 and 15 meters. So it the factor that determines how deep it can grow is really light penetration. So areas where water clarity is greater, the kelp can grow in deeper areas, and again, it grows so fast that even at 20 meters, it's able to grow up to the surface. Different communities of fish and invertebrates down at the bottom versus the middle of the water column versus the canopy. It's really like being in a forest and all the different layers of the forest.
Yeah.
We see that in kelp forests, yeah. And then that productivity, I mean, kelp one of the basic values of kelp is the food that it produces for all the other species that eat it, right? And so because it grows so fast, it's that incredible productivity then goes up through the food web. So it supports invertebrates like lobster and sea urchin and abalone, and the higher level fish, all the different species of fish in the kelp forest, and marine mammals and seabirds. And so it's really the foundation of this incredibly productive and diverse and important ecosystem. Kelp is vulnerable to warming temperatures. Yeah. And so, we're seeing oceans warm all over the world. We're seeing increases in the frequency and intensity of marine heat waves, and that's a problem for kelp. So there are certain places around the world where ocean warming or marine heat waves have caused large losses of kelp, and that's a big concern of ours.
Some colleague of you told me that there is this idea to use the kelp or sargassos, for example, to try to catch the CO2 and that's a
really interesting idea. So there's general agreement that humans are probably going to have to figure out ways to take out carbon from the atmosphere. And there's all these different ways of trying to do that. And scientists have targeted growing kelp as one of those options. So because it grows so fast, if you can create these massive farms of kelp, and then the challenge is, what do you do with that? And so you need to store that somewhere where it's not going to be re-released back in the atmosphere.
Sure.
And so the idea is, massive farms of kelp, drop it to depths where it's going to be stored.
Negative.
Exactly, be stored and not re-release carbon. I think those are still very preliminary ideas. There's a lot of technical challenges that would be very expensive to do that, but it's a feasible carbon removal strategy.
And it's possible to make it growing up. I mean, to plant.
Yeah, it's possible to cultivate kelp. If when you see a decline in kelp abundance, it's often not necessary to go back and replant it. If there's some kelp in the area, it can naturally reproduce. So the situation often what you need to do is just improve the conditions of the ocean, of the local conditions, and kelp will recover on its own. But there is a lot of interest in growing kelp for different purposes, for food, for aquaculture, for things like biofuels or other additives, and for carbon sequestration. So there's an increasing interest in farming kelp on larger scales.
And if you cut the kelp in the top like that,
yep,
you don't kill the plant.
Yeah, not for giant kelp. For giant kelp, you can cut the top. It doesn't kill the plant, and then
it grows
very fast. Yeah.
So basically, one thing we should or we can do is to have a lot of kelp and cut it every 3 days, pack and sink.
That's the idea. The globe is warming, and so it's not going to be easy to reverse that in the short term. So I think one strategy is kelp is affected negatively by warm temperatures, but also there's these local pressures, right? So for example, kelp gets grazed by sea urchins, and if you have a imbalance in the food web, if you overfish all of the large predators that keep the sea urchins in control, the sea urchin populations can explode and graze the kelp. And what we've seen is it's this combination of factors. It's the warming plus the sea urchin grazing, or it's the warming plus the poor water quality that causes these big, long declines in kelp abundance.
Yeah.
So while we're not going to be able to turn down the temperature, we can address some of the local stressors, right? We can have policies that improve water quality, or we can have marine protected areas that protect the higher trophic levels. And if we take off some of those local stressors, kelp can be quite resilient to a degree, to an extent.
And what about the mangrove? You study also mangrove?
I've studied mangroves. The power of mangroves is they store so much carbon in the sediment. So whereas kelp is growing fast, it's also dying fast. And so when it dies, it re-releases the carbon. That's why, to store the carbon, we'd have to haul it out to the depth and dump it somewhere. Whereas mangroves are doing that in place. Yeah, they're if you dig down into mangrove soil, that's all just carbon that's going to be locked away for a long time, as long as it's protected.
Yeah.
Restoring mangroves is very valuable. It's especially important to protect the mangroves that exist, because it's a otherwise you're fast tracking carbon up into the atmosphere.
Yeah.
My motivation isn't necessarily just to save the world. I just love coastal ecosystems, and that love makes me care for them. But I think what we also need is people translating the science into policy, and I see a lot of interest among young people to do that, which I think is fantastic. I'm not the greatest spokesperson for specific policies or specific restoration activities, but I work with people that are very good at that translation, about taking these scientific studies, figuring out how to implement policies that can protect these ecosystems. So that part is important too.
Yeah.
And I see a lot of young people that are concerned about climate change, they're concerned about environmental degradation, that want to focus their careers on addressing these issues.
You are positive.
I'm an optimist about aquaculture if it's well planned and managed.